divisibility 2, the division algorithm. Let's study more about divisibility of integers. Now, if A divides B and B divides A, what can we say about A and B? First, because we say A divides B, then that means we need to assume A is not 0, because if A is 0, then the division is undefined. And therefore, similarly, when we say B divides A, then automatically we assume B is not 0. So on the other hand, when we have this A divides B, that means there is a integer Q, so that B can be written as Q times A, right? That's what we mean by A divides B. And then similarly, there is another integer for B divides A, so say it's K, and then A can be written as K times B, right? So you have, now if you look at this, B equals Q times A, but A is K times B, so you replace A with K times B. Now because B is not 0, so divided by B on this equality, you can cancel the B, then this is 1, so you end up with 1 equals Q times K, right? And further, we also know that Q and K, so let me just write Q is not 0 and K is not 0, right? Because if Q is 0, then 0 times anything will be 0, you get 1 equals 0. That's a contradiction. So Q cannot be 0. And then for the same reason, K cannot be 0. Otherwise, this will be 0, then you'll end up with 1 equals 0. That's a contradiction again. So it's good to see that both Q and K are not 0. But since Q and K are integers, and they are not 0, so what can you say? Then Q and K must be either 1 or -1, right? So say if they are not 0 and then they are integers, then the product need to be 1, so Q need to be 1 and K need to be 1, so that 1 times 1 will be equal to 1, right? If they are not, then next integer will be 2 or -2, something like that. Then the multiplication will not be equal to 1. So you have this, then Q and K must be 1, right? Or another possibility will be Q equals -1 and K equals -1. This also multiplication will be 1 and -1 times -1, you still get 1. So then you can say this. Then when you go back over here, then you see A equals K times B. If K is 1, then that means A equals B, right? So, and then if Q equals 1, that means B equals A as well. So therefore, you can come up with, if Q is 1, K equals 1, then B equals A. If Q equals -1, K equals -1, then you come up with B equals -A from either this or this, right? So therefore, we have this theorem that is in the book, and what we did just now actually is the proof of this theorem. So we state this more formally. So suppose A and B are non-zero integers. If A divides B and B divides A, then A equals plus or minus B. And we did the proof just now. Now further, let's consider more about this divisibility. So say A divides B. Let's look at a very simple example, say 8 divides 24. So 8 divides 24, and you know 8 is less than 24, right? And then you could also write -8 divides 24. So negative 8 is less than 24. So negative 8 is less than 24. But further, you actually can say that absolute value of negative 8 is less than 24. But anyway, if you also write negative 8, it divides negative 24, you can come up with absolute value of negative 8 is less than absolute value of negative 24. You probably know what we are going to make a conclusion. But is there an exception? So if you look at this, say, any number, say 3 divides 0, right? So 0 is divisible by any number, of course it divides 0. But follow the same pattern. Do you get 3 is less than 0? Of course not. Okay. So now with this discussion, we can come up with another theorem that is also in the book. Suppose, so we want to avoid something like this. So suppose A and B are non-zero integers. If A divides B, then we can make a conclusion that A is less than or equal to absolute, then absolute value A is less than or equal to absolute value B. So our discussion just now can show you, already you had the idea how we are going to prove. Okay, so first, based on A divides B, now this means B can be written as Q times A for some integer Q, right? So if you take absolute value, so you get absolute value B equals absolute value Q times A, and we did this one when we studied proof techniques. We proved this one as exercise, then equals absolute value Q times absolute value A. So now we can see that, and Q is not 0, right? Because by contradiction, if Q is 0, then B equals Q times A means 0 times A equals 0. But this contradicts to A and B are non-zero, right? This is a contradiction. So therefore Q is not 0. But since Q is not 0, then absolute value Q should be greater than or equal to 1, right? Because Q is an integer for division here. So the quotient must be an integer. When it is not 0, then the smallest integer, positive integer, would be 1. Therefore, we can be certain that absolute value Q is greater than 1. And then two sides multiplied by absolute value A. So you times absolute value A on the side, and then times absolute, and then this side times absolute value A. And then this is absolute value B. So we proved this theorem. Okay. So just now we discussed about, divisibility. What about if A does not divide B? What can we say? So for example, like 8 does not divide 25. When it is not divide, when 8 does not divide 25, then 25 can be written as 3 times 8 plus 1, right? 25 divided by 8, you get 3, and remainder is 1. So this is always true there for any integers, division. And this is called the division algorithm. So theorem, the division algorithm, that A, B, be integers. So we use a symbol for easiness. Assuming A is not 0, then there is a unique integer Q in R such that for A divides B, A does not divide B, then B equals Q times A plus R. So Q is called quotient, right, as we have known. And then A is called the divisor. R is called the remainder, as we know. And further, you know that when you talk about this, then R will be a positive number greater than 0 and less than the divisor, right, when you do the division. So when you do any division, for example, say 27 divided by 4, you will put 6 here. So you get 4 times 6 is 24, and then 7 minus 4, you get 3, right? So this is the quotient, and this is the divisor, and this is the remainder. So the remainder is greater than 0, less than A, okay? And it could be 0, then that means A divides B then. So this is the division algorithm. Now let's look at an example to, write 876 over 24 in terms of the division algorithm. Well, this is an easy exercise, and kids in elementary school probably know how to do it, but we just want to review and then give you another further question. So 876 divided by 24, you may put 3 here. So 3 times 4, you get 12. 2 times 3 is 6 plus 1 from 12, you get 72. And then 7 minus 2, you get 5. 8 minus 7, you get 1. You have 156. And then you put 6 here. So 6 times 4, you get 24. And then 6 times 2, you get 12, plus 2 from 24, you get 144. And then 6 minus 4, you get 2. 5 minus 4, you get 1. So therefore, this answer will be 876. Can be written as the quotient is 36 times the divisor plus the remainder, okay? Now, this will be different. 876 divided by negative 24. So how do you write this one in terms of the division algorithm? Well, if you do the same, then you have 876 times 20 divided by 24, and then you do the same exactly like this one, okay? Then what you do? So 876, this is negative 24 times the quotient is 36. So the remainder is 12 plus 12. Is this correct? Let's pick up a calculator and see if this is correct. So we take a calculator, and then we take 36 times negative 24. Okay, so 36 times, let me put 24, and then you get it here, but then this is, it's negative, so you put negative there. And then plus 12, but that's this gives you negative 852. It's not negative 876. So what's wrong here? How do you fix it? So then this will be, if you think, oh, should the remainder be minus 12? Okay. Then if you do this again, similarly, so you take 36 times 24, and then negative minus 12, you do get negative 876. So mathematically, this is correct. However, the division algorithm requires that the remainder is greater than or equal to 0. But your remainder now, you wrote it, is negative 12. So this is not correct. So to do that, what you should do actually is 36 times negative 24, and then this is 12. That's the remainder by the calculation here. But we want to, sorry, this is wrong. So we write this one as negative 12. So, but because the divisor is 24, so we need to make this one to 24. But then still, so to balance this negative 12, you need to do plus 12. So negative 24 plus 12 will be negative 12, and this is the same, so that will give you negative 876. And then 36, if you factor negative 24, you get 36 plus 1, right? So you have 37 times negative 24 plus 12. So now the remainder is 24, and this is correct writing in terms of the division algorithm. So you need to be very careful when you deal with negative numbers. Let's look at this example, and it is in a book, that A and B be natural numbers that leave a remainder of 2 when divided by 7. Show that 7 divides A minus B. So let's look at this one. To see how we prove this one, first let's analyze this. So if we want to show 7 divides A minus B, in terms of definition, we know that A minus B equals some number times 7. This would be the quotient. So if we can demonstrate this, then this question is proved. Then let's look at what we are given here. So A and B are natural numbers, and when they are divided by 7, the remainder is 2. So then, based on the division algorithm, say B is divided by 7, then the remainder is 2. So you have a quotient, say S, then times 7 plus 2, right? So that's what B divided by 7, and the quotient times 7 plus the remainder is 2. Similarly, A divided by 7, then you have another quotient, and the remainder is also 2. So if you take A minus B, A minus B, then this minus this, then you get 7t minus 7s, but 2 cancel. You can factor 7, so you get t minus s times 7. So this give you the idea of how we prove this. So prove, and since the remainder is 2 when b is divided by 7, and similarly a is divided by 7. So there exist integers s and t such that b equals s times 7 plus 2 and a equals t times 7 plus 2. So you take a minus b, then this minus this, you get s times 7 minus t times 7 minus s times 7. Then you factor 7, you get t minus s. So because a minus b can be written as 7 times this, so 7 divides a minus b, and this is the proof. Your homework assignment, please see our handout on assignment 28. Thank you.